This is Unit 2, Lesson 3. We're going to talk about line of best fit. And when we talk about line of best fit, we also need to talk about scatter plots and how they work. We need to talk about positive, negative, and no correlation. So let's do that first. We've talked about positive slope and negative slope before, and that is what positive and negative correlation kind of means. If you have a positive correlation, that means that your ordered pairs that you have in your scatter plot go up toward the right. If you have a negative correlation, your ordered pairs in your scatter plot will go up toward the left. And if it has no correlation at all, your scatter plot has points all over the place, and there's really no way you can tell whether it's positive or negative correlation. Now, if it is a positive correlation, then you're going to have two things that relate to each other, and both of them are getting bigger at the same time. For example, just a real simple example, if you go to the grocery store and you buy 3 apples, let's just say they're 50 cents a piece, okay? Well, if you buy 3 apples, the price is going to be $1.50. But if you buy 10 apples, your price is going to go up to $5. So as the number of apples increases, so does the price, which makes sense. The more you buy, usually the more it costs. So that's a positive correlation. An example of a negative correlation would be something where as one thing increases, the other thing is decreasing. So a good example of that might be, let's say you're a person, you're trying to lose weight. And we're talking about, let's say you have just a regular 2,000 calorie diet, you're not going to eat more or less than 2,000 calories per day. Then a negative correlation example would be, the more you exercise, the less you weigh. So your weight is going down as the amount of time you exercise goes up. That's an example of a negative correlation. Now, there are always things within the situation that you're talking about that could keep that from happening. But just in a perfect world, you know, what would you think would happen the more you exercise? If you eat a standard diet every day, you would think you would lose weight. So as the amount of exercise goes up, your weight will go down. So that's a negative correlation. One thing is getting bigger as the other is getting smaller. And then no correlation, well, that's exactly what it sounds like. If you have two different things that have nothing to do with each other, like, I don't know, maybe the price of eggs in your hometown and how it relates to the number of children with chicken pox in Japan. Well, those two things have nothing to do with each other. So they have no correlation. There's no mathematical type of correlation that you can get between those two things. So that would be an example of no correlation. So behind me here on the graph, I have a scatter plot. And basically with a scatter plot, it's just a collection of data, and that collection of data is graphed. And what we do with something like this is we try to figure out what the line of best fit for a scatter plot like that would be. And you can come up with an estimate for your equation, but most of the time, if you're tested on this, it's usually multiple choice, because with these ordered pairs, we can't tell exactly where they are. So there's no way we can do a computer-generated equation. We just have to do a good estimate based on what we can see in this graph. So what I tend to do is I take a ruler or yardstick, meter stick, whatever you've got available, something that's straight, and I just kind of try to put that meter stick somewhere in the middle of all those points so that it looks like it's kind of going parallel to the line that is kind of suggesting there. And so if I do that, I'd say, okay, that looks pretty good. That's kind of in the middle of all the different points. And we can kind of get a good estimate of what's happening here. Well, first of all, we can see that it's going up toward the right. So we know the slope of the line of best fit here is going to be positive. So if our choices have a negative slope, they can be eliminated, because if it were a negative slope, our meter stick would be going this direction. So looking at this, I know it's a positive slope, so I'm going to eliminate anything with a negative slope. So I can eliminate A there. That's got y equals mx plus b, remember, from the last section. So that's a negative slope. I can eliminate it. And then the second thing that I need to look at is okay, which one of these, or where does this cross the y-axis, or where is a good estimate for that? And I'm saying that maybe my estimate for the line of best fit and where it crosses the y-axis, my y-intercept here would be at about 2. So I need to have a positive 2. And another thing you can think of is it is crossing above the x-axis. You can tell that, so we know our y value is going to be positive, or our y-intercept is going to be positive. So I'm going to eliminate any y-intercept that is negative. So that means I can eliminate C here. And then the next thing I need to do is try and distinguish which slope looks better, the 2x plus 2 or the 1/2 x plus 2 in B and D. Well, let's think about that. If I had a slope of, let's just do the first one, 2x. I'm just going to pick a random point up here. And I want you to look at what the slope of 2 would look like. I would go up to right 1, up to right 1. So my slope, if my slope is a 2, is going to be very steep, like that. Now compare that slope to what you've got here. It's pretty steep, okay? Well, it doesn't look quite that steep to me, so let's look at what a 1/2 slope would look like. I'll put it down here and see if maybe it's more of a parallel. 1/2 would be up 1, right 2, up 1, right 2. So if I look at that slope, that looks like it would be pretty parallel to what this is. So my slope, probably the best estimate there, would be a positive 1/2. So I'm going to pick D as my best answer for the line of best fit. Now, with this is just an estimate. We are not going to be able to find the exact value of the line of best fit unless we know the exact value of these ordered pairs. And since most of them are on fractions, we're not going to be able to tell where they are. So this is the best way I can find the line of best fit for something like this. We're also going to learn how to do this with a set of ordered pairs, and we'll use a computer for that because that we can find a pretty good answer for. Here your directions tell you to use Desmos to find the line of best fit. And then I've got some data here. We're given some basketball data, points scored in 10 games, and it's based off of how many minutes a player played and the number of points that players scored. So what I need you to do now is copy this data down in your notes, and I'm going to show you in Desmos how to put this data into your computer and generate a very accurate line of best fit equation. And then we're going to take that line of best fit equation to predict how many points a player is expected to score if they play these number of minutes. So I'll give you some time. Go ahead, pause the video, copy this down, and then we will learn how to do this in Desmos. Okay, so I've gone to desmos.com. Once you get into Desmos, you click the graphing calculator. Down here, if your teacher gives you a class code, you can go to student, type in the class code and join. And sometimes your teacher might have activities here for you. If you're a teacher, you would go here, of course. But if you just want the graphing calculator, you're going to click graphing calculator. And then you can see Desmos. Now, real quick, I'm going to show you just some real basic things about the graphing calculator. I can type any linear equation in here, or really any equation, it doesn't have to be linear, in here, and it will graph whatever I type in. So let's say I'm going to type in 2x plus 3y equals 6. There's the line. So it's real simple graphing calculator. You don't have to have this in slope-intercept form for it to graph the equation. Desmos does make things a lot easier. The problem with Desmos is I think it does too much, and sometimes kids rely on it as a crutch instead of a tool, and that causes some problems down the road. So please don't use Desmos to shortchange yourself. You really need to learn the skills. So to get out of that, you can just click the X here. That will delete that line. You could also backspace. It will delete it there. So what we want to do here is we want to graph the data that I gave you, and it should be in your notes, it should be on your paper. So to graph that data, you're going to click the little plus sign up here. If you click that, you're given some choices here. We're going to go to table. So I'm going to click on table, and notice it gives me an X1 and a Y1. This is where I'm going to put my data. So in that first example, points scored in 10 games, your minutes of playtime is going to be in your X column, and your points scored will be in your Y column. Okay. Now there are a lot of fancy things you can do with Desmos. I'm not going to show you all that stuff, but you can play around with it if you want, want your lines a different color or points a different color, anything like that. So looking at my data here, it says minutes played. I've got 28. And if I just hit return, I can go to the next column or the next row, 35. So go ahead and put that information in. Then to go to the Y column, I just click up here beside the 28 and put the point scored that corresponds to the minutes played of 28. So that would be 16. So go ahead and put that data in. Once you have the data in there, Desmos will graph the ordered pairs. You can go over here and kind of see the ordered pairs if I scroll over. So you can see that the ordered pairs are there. But it really doesn't matter so much what the graph looks like as what's going to go on over here. So what I want to do is I want to tell Desmos to generate an equation for that data. And in order to do that, down in the next row here, row 2, I want to tell Desmos to generate a y equals mx plus b equation for me. So to do that, basically what we've got here is we've got an x1 column and a y1 column. So in my equation, I'm going to use that notation for my y equals mx plus b. Instead of using y, I'm going to use y1. Instead of using x, I'm going to use x1. That tells Desmos that we're considering all of these ordered pairs to generate that equation. So what I'm going to do is I'm going to type in y1, and now in order to get Desmos to find the equation for it, we're not going to hit equals, we're going to hit the tilde sign. So that is shift, and it's the key just to the left of the number 1 on your keyboard. So y1 tilde, and then we're going to type m times x1 plus b. Okay, now you can see there that Desmos, if I just pull this around here, has kind of drawn a line of best fit, kind of like I did on that graph earlier. So it draws the line of best fit for you. And then if you look down here at the bottom of row 2 here, it tells you that M is 0.774605 and B is negative 5.80036. So it gives you what the equation of the line is. Okay, so I'm going to take that information and I'm going to write that equation here. So I'm going to say y equals 0.774605 x, and it's a negative 5.80036, so I'm going to put minus 5.80036. There is the equation that they have generated for me for the line of best fit here. So that would be the line of best fit. Now, I also ask you, does this have a positive, negative, or no correlation? I ask for the correlation. Well, if you look at the direction this line is going, it's in a positive direction. So this has a positive correlation. We can also justify that by saying that the slope here is positive. Okay, so now I've got the equation for that line here. What I'm going to do next, I want to predict what those other scores would be. So at the last thing you copied down, it said predict the number of points scored if the player plays, and it said 45 minutes, 10 minutes, 25 minutes, and 60 minutes. So that's what we're going to do next. So in order to do that, I can get rid of this data because I've already generated my equation. So be careful not to delete your row number 3, the equation that we generated. But I'm going to quickly get rid of the other information. Now I just have this line. So if I want to generate or figure out where or how many points are scored after 45 minutes, remember your number of minutes played was your X value. So what I can do is I can go down here to row 2, and I want my X value to equal 45. So I'm going to type X equals 45. And then that line should be graphed over here in this color, and it's going to be green. So I'm going to scroll over here until I get to 45. There's the 45 line, and I'm going to scroll up until those two lines intersect. And if I do that, I can click where those two lines intersect, and it gives me the ordered pair. It's at 45, 29.057. So I would say that if I played 45 minutes, I'm expected to score about 29 points. All right, so let's eliminate that, and let's do the second one. Let's do 10 minutes. So in here, I'm going to put X equals 10. And then I'm going to scroll back to where X equals 10 would be. So this is kind of time consuming. I don't think Desmos is necessarily saving us any time here, but it does keep us from having to do anything by hand. There's the ordered pair. I just click on it. At 10, the number of points I'm expected to score is 1.946. I would round that to 2 points. Okay. I'm going to get rid of that, put the next one in, or I'll tell you what, you go ahead and put in X equals 25 and see what you're getting for your Y value, the number of points, and then put in X equals 60 and see what you're getting for your number of points. So here is my X equals 25 point. So at 25 minutes, the player is scoring 13.565, so I would say that's about 14 points. I would always round to the nearest whole number. And here at 60, I have 40.676, so I would say at 60 minutes of play, we would score 41 points. If you want to zoom in or zoom out, you can do that with this plus and minus here. So that's zooming in, zooming out. Okay. If you want to delete these, you just X out of them, go home, or go to the default zoom is taking you back to 10 to 10 on the ordered pair or the coordinate system. We're going to do the same thing with some more information here. Since now we've learned how to do these in Desmos, I want you to take this data, copy it in your notes, see if you can do this one on your own, and then we will compare our answers. I'll do it in Desmos and walk you through that as well and make sure you're remembering how to do things. So go ahead at this point, pause the video, and you can copy the information, get it into Desmos, and let's see if you remember how to do that. Remember, to get the equation up there or the table up there, you click the plus sign, the table, and that'll give you your XY chart. And then remember down here in 2, and this is something you're going to have to memorize for Desmos. I don't know what to tell you about that. If you're in Virginia and you're taking an SOL, the SOL is going to allow you to use Desmos. So these little tricks in Desmos you need to memorize. The equation for line of best fit is Y1 tilde mx1 plus b. Okay, so go ahead with that. Type in the points that I gave you and see what you end up with. For the second example, I have all of the ordered pairs typed in. One thing I didn't mention before, make sure before you write down the equation that you get in row 2, double check and make sure you haven't made any mistakes in your data. Even one digit being off is going to throw the whole thing off. So you need to be very careful and make sure that all of these numbers are accurate according to what you were given. And then with this, I've got my equation. I'm going to go down here to row 3 and I'm going to type in y equals m is negative 0.149897, and then b is positive, so that'll be a plus. Oh, I forgot my x. Can't forget the x when you're dealing with linear equations. Plus 47.5088. Hit enter. And once you have this equation, go ahead and X all of this information out so that we've got the equation that we need graphed. And let's see if we can find it. There it is. And then the lines are the points that I gave you, or, well, the line of best fit. This is what you would write for the line of best fit. Is it a positive or negative correlation? Hopefully you see that this is a negative correlation. It's going up toward the left. And then for number 2, we wanted to predict the gas mileage for a 210 horsepower. The horsepower is your X value. So X equals 210. And we can zoom in. There's your X equals 210. I'm going to click on those, and 210 gives me a 16.03 miles per gallon. And I would round to the nearest mile per gallon, so 16 would be fine. Okay, so that's line of best fit using Desmos.